All right, so what we're going to look at on Friday, and to start looking at in today's video, is how we take that list that we made using the rational roots theorem and try to whittle it down so we're not feeling like we have to try every single number that list gives us, because sometimes it gives us a lot of numbers. So this guy Descartes, is how you say his name, this mathematician Descartes, discovered this rule of signs that we can use to help us narrow down our list a little bit. So what his rule says, so this is his rule here, rule of signs. Says that you can find out how many positive, negative, and imaginary roots that you're going to have. So if you go through and you use Descartes and you find out you're not going to have any positive answers, well, then you can knock out all the positives from your list. So now you would look at just negatives, or vice versa. So this law of signs helps us with a starting point and helps us to see what can we potentially cross off because we know it's not going to be a part of our answer. So there's two parts to his law. The first is how to tell how many positive. So the number of positive roots, you look at your function f of x and count the number of sign changes. So you're going to look to see how many times do you switch from positive to pluses to minuses or minuses to pluses. However many sign changes you have, that's how many positive roots you could have. Okay, so you could have the number of sign changes or an even amount less. So what that means is if we go through and we count 4 different sign changes, that means we could have 4, or we could have 2, because 2 is an even number less, or we can have none. So in other words, I know I won't have 3 or 1. It's going to either be 4, 2, or 0. Just like if we counted and we had 3 sign changes. Well, what's an even number less than 3? 1. So I'm going to either have 3 or 1, but that means I'm going to have 1. I know I'm going to have a negative, so that might be where I start. Okay, the number of negative roots for this, we look at f of negative x. So kind of like how we did inverses, where we plugged in negative x, or sorry, odd and even, how we plugged in negative x. We're going to do that here. Plug in negative x and count the sign changes. Count the number of sign changes. You could have the number of sign changes or an even number less. So by just again counting the number of times our equation switches from plus to minus, we can narrow down our list of possible solutions. Now, something that I'm not sure if you've gone over before with other classes, but in order to tell how many solutions you're going to have total, you look at your highest degree. So if we look at this first one, f of x, that I have here. Three x to the third minus 5x squared plus 6x minus 4. Okay, right away, I know, because my highest power is a 3, that I'm going to have no more than 3 total solutions. So when I'm going through trying to figure out possibilities, I know I'm going to have 3. So I'm going to use that to help me, and I'll show you how in just a second. So let's start with positive. So positive solutions. I'm going to count my sign changes. So I went from a positive to a negative, that's 1. Negative to positive, that's 2. Positive to negative, that's 3. So I had 3 different sign changes, or 3 different times where I went from a positive to a negative. So that means for my positive, I could have 3 positive answers, or I could have just 1 positive answer. Either way, I'm guaranteed at least 1 positive. So using this with the rational roots, that means I know one of those positives has to work. So I might start with a positive one because I know I have to have one. Now for the negative, I'm going to plug in negative x. So it's 3 negative x to the third, negative x squared, negative x, and minus 4. So here, when we cube a negative, it's going to stay negative. I square a negative, the negative's going to go away, so I can keep the sign that's already there. Here, this will become negative 6x, and then minus 4. So now I'm again going to count how many times does my sign change. So this will be my negative solutions. So when I go negative to negative, no change. Negative to negative, no change. Negative to negative, no change. That means I'm not going to have any negative answers. So from our list of rational roots, I know none of the negatives will work. So I'm only going to focus on my positives. But we do have our third option, and that's our imaginary roots. So the ones that are not rational numbers. So this is where knowing that I have to have a total of 3 answers to solve my quadratic, or to solve my cubic in this case, is going to come into play. So I'm going to look at all my possible options. So I can have 3 positive, 0 negative. So that means I've hit my 3, so I could have 0 imaginary, because 3 plus 0 gives me 3. But what about when I have 1 positive? So if I have my 1 positive, but no negative, that means I have to have 2 imaginary so that I have my 1 plus 0 plus 2 for my total of 3 solutions. So this is what Descartes tells us, or this is what Descartes' rule lets us do. It lets us figure out how many possible solutions that we could have, whether it be positive and negative rationals or imaginary, so that we can maybe more quickly try to figure out one of our factors that we can try with synthetic division. Okay, so let's see. I have another one that we can do with Descartes in class to help us, but if you have questions on this, make note of them, and we'll do another one in class just to make sure we all understand how to use Descartes. The second half of this is using upper and lower bound. Okay, what upper and lower bound help us to determine are values that we know we're not going to go above and values we know we're not going to go below. So as we're practicing or as we're testing numbers, if a certain pattern happens, then we know that that's an upper bound, meaning I don't need to try anything higher because I know it won't work. That's because that value was upper. Same thing with lower. If you notice a certain pattern with your answers, and I'll go over that pattern here in a second, you'll notice that if this happens, then that means you just found a lower bound, meaning you're not having anything lower than this number, so you've kind of narrowed it down from an upper and lower perspective. So let's start with a function, because this will all make hopefully more sense after we do one with a function. Okay, we're going to start by using our rational roots theorem to find out our potential solutions. So I'm going to start by listing my P over Q's. So my factors of 6 are 1, 2, 3, and 6. For 2, it's 1 and 2. So if you remember from our rational roots, these are the P's, these are the Q's. So when we go to write, we'll have plus or minus 1 over 1, 1 over 2, 1 over 3, and 1 over 6. So that was me just putting 1 on top of all 4 of these. Now I'm going to do the same thing with 2. Plus or minus 2 over 1, plus or minus 2 over 2, well I already have 1 so I don't need to write that again, plus or minus 2 over 3, plus or minus 2 over 6, well 2 over 6 is 1/3 and I already have that written down. So we've got all of our potential solutions here, so I don't need this here. So if you are doing your P over Q's and you notice you have some repeats, you only need to write it once, so you don't worry about writing it more than once. Okay, so those are all of our possible rational solutions. So the next thing I'm going to do is I'm going to look to see how many positive or negative solutions I could have. So positive solutions, I come to look at my sign changes. So positive to negative, that's 1. Negative to positive, that's 2. Positive to negative, that's 3. So I can have 3 or 1 positive solutions. For negative solutions, let's see, this will become negative 6x to the 3rd. The negative would square away, giving me negative 4x to the 2nd, making that negative and minus 2. So that was me just plugging in negative x. If you need to do the step where you show the negative x and then simplify, that's fine. I skipped it. We can go through that if need be though in class, so you can see how we get this. And so what do I notice that there's no sign change whatsoever. So we have 0 negative solutions. So right away, what does that tell me? I can come up to my list, cross off all the negative solutions that I could possibly get, because I know none of them will work. So we've just taken our list and halved it. Okay, and so then for imaginary solutions, see 3, I know I have to have a total of 3. So 3 plus 0, I already got my 3. 1 plus 0 means I need 2 more imaginary solutions to make my total of 3. So from here, I've got my list as narrowed down as I can possibly get at the moment. So let's pick a positive number. So I'm going to start with 1 because it's the first one on the list. So 1, and I list out 6, negative 4, 3, negative 2, and we're using the original function. Bring down the 6. 1 times 6 is 6. Add. 1 times 2 is 2. add. 1 times 5 is 5. And we have a remainder of 3. So if this happens, so what I want you to notice is that we have all positive. So we didn't have anything that was negative in our solution to our synthetic. Now it didn't go evenly, but I got all positive. So if you ever get all positive or zeros, then you have an upper bound. Okay, so 1 didn't work, so I'm going to cross off 1 because that one didn't go in evenly. But I've also now determined that 1 is I can't have anything higher than 1 because that's an upper bound because I got all positives in my synthetic division. So I can also, because knowing that I can't have anything bigger, I can cross off 2 because 2 is bigger than 1. So now I definitely have to have a fraction. So let's pick another one. We can kind of just go down the list. If we do 1/2, so 6, -4, 3, -2. Bring down the 6. 1/2 times 6 is 3. Add. This will give us -1/2. Add 2.5. Actually, I'm going to put that as an improper fraction to make it a little bit easier. 5/2. So then when we multiply, we get 5/4. So when we subtract, we'll get, let's see, that's -1, 3/4. That's -8/4. Yeah, okay. And it's going to be negative. So, did we get all positives to see if 1/2 is an upper bound? So here we didn't get all positives, so that tells me, okay, that it's not an upper bound, so I'm not tied to higher or lower. But what I do notice is that I have alternating signs. So when the signs alternate, positive, negative throughout your synthetic division, that means you have a lower bound. So what that means is I'm not going to have anything smaller than 1/2. So I can go to my list, so I just showed that 1/2 didn't work, but I'm also not going to have anything smaller than 1/2. So I look to see on my list, is there anything else that's smaller than 1/2 that I can ignore or cross out? Let's see, 1/3, that's bigger, but 1/6 is smaller, so I know 1/6 won't work either. So now I've only had to do synthetic division twice, and I've got my list narrowed down to 2 potential answers. So to put you out of your misery, I'm going to do 2/3 because I know that one works. So we'll do 6, -4, 3, -2. Bring down the 6. 6 times 2/3 is 4. 0. 2/3. Nope, not 2/3. What am I doing? 0 times anything is 0. So 3, 2, 0. So this means it divided evenly. So I know that I have my factor x minus 2/3. That comes from the one that worked. And I'll have 6x squared plus 3 as my other factor. So I know that this was my only real solution. From here, if we were actually going to continue to solve to find the other solutions, to know if we have 3 positive or if we have 2 imaginary, we would take the factor we have and solve it. So x squared equals -3/6, and when we square root it, we get plus minus -1/2. So that means I have 2 imaginary, and then I have my 1 real solution of 2/3 that we found with synthetic. Okay, so again, this is everything in one problem. So that was a long one. We can do another one in class just to make sure we've got the process. The key thing that I wanted to point out were these 2 things. That as you're testing numbers from your list that you've created using the rational root theorem, and you've already tried to narrow it down using Dakar, that as you go through and test numbers, you want to look for these 2 patterns. So did you do synthetic and get all positives? Because if you did, that means that's an upper bound. So you know you're not going to have any numbers higher than 1. So it lets you narrow down your list a little more. When you plug something in and you get alternating signs, that means you have a lower bound, meaning you're not going to have anything smaller. So that means you can cross off anything smaller than the value that gave you that pattern. So upper and lower bound is another tool we have to help us narrow down our list from what we had as we go to even smaller and smaller amounts. Okay, so like I said, we can do another, we'll do another just Dakar. So this part only was Dakar. We'll also do another one where we do the whole thing, looking for upper and lower bounds to help us narrow our list. So come with questions, and we'll do one more of each before we start our homework. But this is probably, I think this is pretty much the last bit, and this is about as long as your problems will get. So hopefully that's a good thing.